Hello class, how are you? This is me again, Mary Grace A. Curicot, and one of the presenter of Chapter 18, which is entitled Calculating Profit, Revenue, and Cost. Together with me, Ida May, Prussia. We are from BTBTF 3A. And if you're ready, let's begin! So now we are in Chapter 18, which is entitled Calculating Profit, Revenue, and Cost. In this chapter, it talks about balancing revenue and cost for a profit, discovering costs and how to predict them, and breaking even in business. Actually, Chapter 18 is one and the most important chapter in business mathematics because it actually helps the business or the small business to run, to become successful, and as well as to grow the business. So let's start in figuring profit from revenue and cost. So profit is actually a good thing, but in order to earn more profit, you have to have fewer expenses or lower expenses than you do income. Your cost of providing merchandise or a service has to be less than what you paid to provide the goods or services. So here's the general formula in relating profit, revenue, and cost. So profit is equals to revenue minus the cost. So next is understanding how volume affects profit and cost. One of the simpler models or examples of profit, revenue, and cost is actually driven completely by volume. When we say volume, that's the number of items that you produce or sold. So let's say, for example, if I produce cupcakes for 20 pesos per piece, which actually includes the cost of materials, the cost of ingredients, the packaging. And if I were going to sell that cupcakes for 50 per piece, so these equations give you your profit. P, which is your P. When you sell X, that's the number of pieces of cupcakes. So here is the equation. So the notation P of X in the profit equation is actually called function notation. When we say the notation of P of X, where your X there is the input amount used to evaluate equation, P to get an answer. So the variable X actually represents the number of items. So in the revenue part of the equation, it's the price multiplied by X. In the cost part of the equation, it's the cost per item multiplied by X. So the difference found with algebraic subtraction. So in simplest explanation, you just need to follow the equation that I gave you earlier and you do the subtraction, and that's it. Now, what if you have 100 pieces of cupcakes? How much is your profit? And also, how many pieces of cupcakes do you have to sell to make a profit of 5,000 pesos? So, using this formula, P of X, you just let X be 100. So since you'll be having 100 pieces of cupcakes, you just simply replace X to 100. So you put the 100 in for the value of X and then multiply by 30. Then you will get the answer of 3,000 pesos. So you make 3,000 pesos for selling 100 cups of. To determine how many cups of lemonade that you need or that I need to sell to make a 5,000 profit, So you just simply replace P of X in the formula with 5,000, and then you solve for X, the number of pieces. So your equation looks like this. So 5,000 is equals to 30x. So now you divide both sides of equations by 30 to get about 166.6, or you just simply round off to 167. So this will solve the number of pieces that you need to sell to make a profit of 5,000. So next, seeing how price is sensitive to demand. So this is very common to us. A common characteristic of price in relation to the number of items sold is this. The lower the price, the more items tend to sell. It will actually take a fine balance of course, between lowering or raising enough, but not too much. So the table 18.1 is actually informative when it comes to determining the effects of lowering prices. And next is using an equation for demand. When we say a demand equation, it's actually used to represent the effect of a drop in price. So when we say demand equation, it's actually a projection or prediction of what sales volume will be based on the price, or what the price should be based on estimated sales volume. Example, instead of saying that the revenue is R 10x, meaning that each item will sell for $10, you use the revenue function for R is equals to P of X, showing that the price of P, which is the P, it actually changes the volume of X. So consider the situation where the company determines that it can increase the number of donuts sold by 400 for each drop of $0.50 in price. So as you can see stable earlier, that there is the effect of lowering the prices. So in that situation, the following demand equation can be used. So this is the demand equation where X is the number of items expected to be sold if the price is P, because a profit equation uses the price being charged, P, and the number of items being sold by X. Then you solve the equation of P like this. So X, just substitute 4 plus 400. So you do the computation. So X is equal to 4 cancel out 400, we'll make it 800, and then the rest of it. So you just need to follow the computation of equations. So using the equation to find the price, which is the P, you see that the X is the usual 2.4, the price is. So this is it. At a level of 2.8 sales, the price is, this is also the result. So it's a 14.50. So these values are the same that you find in table 18.1, the table that I showed you earlier. So you can see from the demand equation that there's a limit on what X can be. Let's say, for example, if you let X be a number greater than 14,400, you get a negative price. You can specify that the equation applies only to volume within the certain range. You may say that X must be less than 1 million, or between 100 and 500, or some such concentrates. So such guidelines are set to keep the price above a particular number so that the profit is a positive number. So the following examples shows how to use the demand equation to find a profit. So let's say, for example, suppose that the Dodans will actually sell for $15 regularly, but the company's marketing division has determined that Dodans sell better if the price is reduced. So discounted price. So the demand function that reflects an additional 400 sales for each $0.50 reduction is, so P is equals to 14,400 minus X over 800. So where your P is the price when X is the Dodans are sold, so how many Dodans are sold, then constructing a dotted cost of the company of $8.50. So what's the profit when the company sells 2,400 Dodans? So how about if when it sells 3,600 Dodans and 4,200 Dodans? So to figure this problem, you just simply use the profit equation. Profit is equals to revenue. When you say profit equation, that's the equation that I presented you earlier, which is the profit is equals to revenue minus the cost. So you just need to fill in the revenue part of the formula by multiplying the price per Dodan, P by the number of items of X. Then you'd subtract the cost of 8.50X. So equation look like this. P is equals to P of X minus 8.50X. Now, you insert the demand equation for the P is what it looks like below. And then the profit equation can be simplified with algebra. But I'm just going to leave it for now to show the substitution for X. I will let the X be the 2,400 or 3,600 and 5,200. So here are the resulting profits of each number. So when the price is 2,400, you get earned 15,600. When it price of 3,600, it will yield, it will result to 18,000. And when we say 5,200 or 5,200, it will actually result to 15,600. So from this equation, you can see that the profit increases when the number of Dodans sold goes from 2,400 to 3,600. Remember that the Dodans cost $15. When 2,400 are sold, when 3,600 Dodans are sold, you know that the price has been reduced to 13.50 each. But what happened with the sales of 5,200? Shouldn't increased sales mean more profit? No. That's not the case when the price has been reduced too much. When 5,200 Dodans are sold, the demand equation says that the price has been lowered to $11.50 because the lower the price has offset the increase in the sale. The lower the price, the more sales. Next is sorting out variable and fixed costs. So basically, there are actually two types of cost in production or services. And these are the fixed costs and the variable costs. So let's start with fixed costs. When we say fixed costs, it's actually a part of total cost. When we say fixed cost, it's actually the part of the total cost that's incurred whether you produce anything or not. So it may actually be the use of buildings, the structure, the payments to any salaried employees, the insurances, and so on and so forth. it is actually also named as startup cost. So let's say, for example, if I'm into a cake business industry, I need to buy electric oven or oven. So oven is actually considered my fixed variable. So I'm just paying only once. Now, let's move on to variable cost. When we say variable cost, it's actually a part of total that changes as the number of items being produced and changes. So when it comes to variable cost as well, the more items you produce, the more you have in cost. So let's say, for example, in a lemonade stand, the more cups of lemonade you put together to sell, the more it costs in sugar, in lemons, in paper cups as well. Of course, right? With the large companies, on the other hand, the cost may vary in other way. The amount is charged per item and it may decrease. Well, when supplies are bought in a large quantities or quantities, discounts for volume can make the expenditure per item smaller. So it gives discount because they purchase in bulk, right?
Now let's proceed to figuring in fixed cost. When including fixed costs in the profit formula, you add the fixed amount to the variable amount. Here are the formulas that you may use. Number 1 is total cost is equals to variable cost plus the fixed cost. The other one also is total cost is equals to number of items, is equals to price times number of items plus the constant number. So let's say, for example, the booster club for the Bradley Braves decided to fashion a commemorative t-shirt to celebrate the team's success in the NCAA basketball tournament. The template for the screen printing cost $90. The t-shirt themselves cost $8 each, but it also costs $2 per shirt to get them printed. The Booster Club decided to sell the t-shirt for $12 each. What's the club profit if it sells 300 t-shirts? So the first thing you need to do is to find the total cost for the t-shirts. This actually includes the variable and the fixed cost as well. Start with the variable cost, $8 per shirt plus $2 per shirt of printing. So your total variable cost is $10 per shirt. In the cost formula, the variable part of the total cost is $10 X, where your X there is the number of t-shirts, or the fixed cost is $90. So the total cost is written like this: C of X is equals to 10X plus 90. So the revenue part of the profit equation is written by as 12X because the shirt will be sold for $12 each. But putting the revenue and cost portion into the profit equation is simplifying. You get P of X is equals to 12X minus 10X plus 90. And then you do the operations and then replace the X in the equation. So you come up with the answers. Now you need to replace the equation with 300. Your X, you need to replace that into 300, which is the amount the club anticipated to sell. And this will give you $510 if you sell 300 t-shirts. Next is examining how variable costs change with volume. The simplest method of figuring the cost of the materials and labor that are needed to produce an item is to take the total amount of expended in materials and labor and divided it by the number of items. This computation gives you the fixed value that's then used in a profit function as the per cost item. So for example, averaging the total cost of an item, one measure is $4,000 to profit, and you've produced 1,000 items. The average cost of the items is $4 pesos. So here's the general formula to find the average cost. Average cost is equals to total cost plus the number of items. When determining a company's profit, you see a formula that subtracts cost from revenue. So this formula gives you the net value, which you hope is a positive number. Determining the revenue for this formula is relatively easy. The money comes in or promises are made, and this allows you to record the income for the product or services. These are the different types of cost. It includes the fixed and the variable cost, the direct and indirect cost, and differential and historical cost. So let's start with dividing up an indirect cost. So let's start with direct cost. It includes anything that can be specifically traceable, accountable to a particular product, service, or purpose. So here are some examples of direct cost. So the materials needed to construct a house, the labor used to install a fence, and the advertising bought to announce a big sale. Now let's proceed to indirect cost. It actually involves surprise costs that are not directly traceable or accountable to a particular product or services. Instead, indirect costs may be associated with two or more difficult products or services of a company or business. So these are the examples of indirect cost. The cost of advertising the different sale items in store, salaries of managers and secretaries not directly involved in the production process, stationery and office supplies, insurance, and heating and cooling. Now let's try this example. Consider a company that makes 4 different products. It will include A, B, C, and D. So here's are the percentage breakdown of each product. In product A, it requires 10% of labor and 20% of machinery time, and if it counts 20% of total of all direct costs. In product B, 30% of the labor, 20% of machine time, and it accounts for 40% direct cost, and so on with the product C and product D. So the total amount of indirect cost per year is $2,500,000. How much the indirect cost? Now, you have to find the amount that each product should be allocated in indirect cost. To do so, multiply the indirect cost by for each product. First, you multiply $2 million by its total percentage without moving the decimal. Then you divide the result by 300. Then you'll be dealing with very large number. But your calculator should be able to take the hit for you. However, take need, I really prefer not to work with such big numbers. It's way too easy to get lost in all the zeros.
And that would be the end of our video. I hope you learned something. See you again in our next video. Bye!